All right, number two, another concept or vocabulary term. It says, what is the difference between velocity and speed of an object moving in a straight line? Velocity can be positive or negative depending on direction, and speed is always negative. Well, actually, speed is the absolute value of velocity. Velocity can be positive or negative depending on direction it's traveling. Speed is always positive. Speed is always positive. B looks good. All right, number three, we have 6 parts. We're going to use the table in this graph, the company graph. Shows the position of a bicyclist T hours. After T hours, we're going to assume S is positive when the bicycle is east of the starting point. So it looks like the bicycle is starting here and it's going east the whole time. The slope is always positive. It never goes negative, which means he's going back over time. So it wants us to determine the average velocity of the bicycle over the first hour of the trip. Okay, so you can pretty much do the slope formula. First hour, we would go from 0 to 1. It's almost a straight line. But if you wanted to do the slope formula, we can see there's an ordered pair 8, 1. And then minus the starting point 0, 0. So y1, y2 minus y1, y2 minus y1 over x2 minus x1. This will just give us 8 over 1 or 8. Okay, just using the slope formula. So we get 8. Find the average velocity over the interval 1 to 2.5. So similar, we'll do the same thing. Now some of these you can kind of look and know what's going on. Since he's positive the whole time, it's not going to be a negative, so I can get rid of A and C, and then probably not going to get a bicycle going 30 miles per hour. 5.3 is more likely, but let's find the actual slope. So if we look at this graph, at 2.5 right here, we are at 16. So we can do 16, 2.5, and then we are subtracting 2.5 to 1. So at 1, he was at a position of 8. And so this will be 8 divided by 1.5. And if we compute that in a calculator, we should get pretty close to about 5.3. The next part says, is the average velocity a good estimate of the instantaneous velocity at t equals 2? So at t equals 2, it looks like the slope right here is kind of like flattening out, like he's coming to a stop. And so I would not say the average velocity, if we pick 2 points going through 2, would be good for the instantaneous velocity at 2, because at 2 looks like he is pretty much coming to a stop and then starting to rest. So we would say no. Part C wants us to find the average velocity of the bicycle over the time interval 2 to 3.5. So at 2, his position is 16. At 3.5, position is about 22. Looks like these are counted by 2. So we would be doing slope again. So 22 and that was 3.5 minus his position at 2. He was at 16 at 2 at 2 hours. And so this is going to give us 6 divided by 1.5. Okay. So roughly about 4, somewhere close to that. Looks like 4 is an answer choice. we're going to estimate the velocity of the bicycle at t equals 0.5. So the velocity at t equals 0.5, I'll just have to use this line again. So it's kind of like a slope. So if you look at its position at 0.5, he's just at 2, which I guess we can look at that and see if that works. That just gives us to that point. Usually I try to use through that point, but let's see. This is position 2 at 0.5 minus 0 at 0, the starting position. But he's still speeding up. This is going to give us 4. Okay, but I know that the whole hour, because we're doing an hour, the first one it was 8. So you don't want to pick 2. 2 is the position, and he's not going to the west. They told us that his position is going to be east as long as it's positive. So I know it's not 2. I know it's not 8 west. So A and B can get rid of those. He hasn't gone 58 the whole time. So I think they're using the slope from 0 to 1. T is right in the middle. And so we're getting 8 miles east. And then part D, describe the movement of the bicycle during the 4 hours of the trip. The movement looks like he is driving or riding east for the first 2 hours, and then he stops for about 30 minutes, and then he starts riding again. So bicycle rides uphill the entire time, rides to the east, takes a break after 2 hours, and then rides west. West would be a negative slope. Bicycle rides east, takes a break after 2 hours, and then rides east again. C looks the best.